All right. Yeah, good morning, guys. Yeah, let's, as usual, let's give the other guys a few moments to, well, we'll start at 8, in 10 past 8. 10 past 8 seems to be a good time for us to start. We are managing to cover all the material that we want to. And also until 10, until, we have 10 minutes, right? So until that time, use that time to think about um, uh, things that are still confusing to you, or things that you would like to see discussed in class today, um, or any other interesting things, right? Any other interesting things that you want to be, we want to explore, and obviously, even if you have advanced concepts that's maybe even beyond 2C, what happens out there in the industry, right? I mean, what is a real hardcore machine learning AI engineer do in their daily job, right? What kinds of data do they process? What kinds of insights do they bring to the picture to look at the data and intuit, right? Because you can have mountains and mountains of data. You can be like Google or Apple, receiving a fire hose of data every microsecond, right? But all of the data is pretty much useless, really. It's trash, because if you look around you in the real world, uh, everywhere you see, it's packed with data. Everywhere, it's packed with data, right? I mean, it's data. I don't mean data in the form of bits and bytes, electronically stored, because at the end of the day, if you think about it, there's data everywhere. The only difference in the data that's stored inside a computer is that it's been translated to bits and bytes in a different form, right? But if you look past the encoding of the data, right? Look past the encoding, look past the surface aspects of the superficial, go deeper, you'll see that it's just data, and everywhere is data. So if I look at a block of wood, that's data, really. But it's not data that we can process so easily in certain forms, right? If it was, on the other hand, if it was digitized completely, at the subatomic level, right? Digitized and stored, then I have a way to process the data electronically. However, if it was digitized, I would not be able to process data in another way, right? I can't process it with my Dremel and turn it into a different shape, but I can process it into a virtual shape, obviously. But so data in certain forms allows itself to be processed in certain ways. So if you want to process data in a different way, then we want to transform that data into the other way, which allows you to process it in a different way, right? So if you have full 3D scans of actors today, right? So if you take an actor who commands $1 million per scene or something like that, and you have a full body scan of that actor, and also we can use machine learning to figure out the most likely response that actor has in a scene with certain stimuli, right? We can fine tune these with time as the model improves. But so with that data and a scanned picture of that person, you can effectively get a virtual actor who is indistinguishable from the real actor and costs pennies, really, right? So you don't have to say, I have this action flick and you got to do this, death-defying scenes, and it will pay you a couple of $1 million if you want to do this, if you agree to do that scene. No, you don't have to, right? You can get that for a couple of cents now. Right? I don't know how much the electricity costs, but you can get that for nothing at all if you have that data, and then you don't have to depend on the actor anymore, right? I mean, you don't have to worry that the actor is going to go, get old and wrinkle face and not able to jump through hoops to do these special effects. You don't have to worry about anything, because you have a perpetually young and able and good looking and actor who would also do what you want them to do, right? Because it's all electronic. And we get that power because we are able to see past the superficial aspects of it, right? In life, everywhere you look, you only see what is available to be seen. You only perceive what is available to your senses to perceive, right? There's a whole lot. You look at the electromagnetic spectrum as an example in the physical world, right? So what tiny sliver of the electromagnetic spectrum is available to our senses, right? If you look at the entire, you can go all the way from 0 hertz to, I don't know, possibly infinite hertz, right? So infinite energy, and maybe at the center of the black hole, you have tremendous energy, right? Gamma rays, X-rays, incredible amounts of energy coming out of there. And then you have 0 hertz in the far reaches of the universe, maybe, right? So there's so much electromagnetic radiation that is possible. And yet the human eye, or even take the other, hummingbirds and bees, right? They can look past the spectrum of human eyes, right? Include electromagnetic waves and ultraviolet rays and so on and so forth, right? So even if you take those, the visible spectrum is like a tiny, almost a zero-sized sliver of the entire thing that is available for perception. If you had a device that is capable of perceiving it, right? There's so much available out there to perceive it. We can't do that. And it's not just with light, right? It's anything, sound, light. So everything, our human perception of, or even biological perception, or any finite perception, any finite organism, whether it's alive in the human sense of the word, or even a mechanistic model, or a camera with a sophisticated AI system, if you're going to observe it and measure it, you are ultimately subscribing to the model that says, this, what we're going to build is based on what we can observe, right? And so, and because we can do things better with a certain perspective, you take the data, that view, and work on the data from here. Now you want to polish it this way, you take a different view and polish it from there. And eventually you try and get to the whole picture. So I think that's how it works. So data representation ultimately is really key to all of these things. Where we're going with that, just trying to fill up the minutes, really, I think. So yeah. So I think it's all super important. You can ask questions about these things, and I'll chime in with my experience of having done a lot of this stuff in the past, and even now, right, when I get some spare time. So I can tell you how we process information for extremely large language models, right? So language models where you calculate probabilities, not just of words, right? So in language models, you could even calculate the probabilities of invisible tokens that are in the word, like pauses, right? And pauses are invisible, but you can calculate the probability that a pause will occur at a particular point in a sentence, right? And you can also, one of my ex-colleagues, I think Gökhan, he published a paper recently. I think I saw it on LinkedIn, but I didn't actually read the paper. But it seems like an obvious step if you think about it, right? So you can not just calculate probabilities for some unseen tokens. You can calculate probabilities of inserted words and deleted words in sentences too, right? So when I speak a sentence to you, maybe habitually I omit certain sentences, or maybe habitually I insert certain words like right? So but you can calculate these probabilities. You can calculate these probabilities, estimate, right? Estimate these probabilities and insert them into the mix. So when you try and recognize the most likely thing that some person spoke, when I say to Alexis, what's the time, right? Alexa picked it up, right? And so you can calculate these things. You can calculate most likely sentences in the user intent, not the one that was actually spoken, right? So the user might actually say, switch off the light, when they actually mean switch on the light. But using machine learning, you can figure out what the user actually mentioned, actually said, and do the right thing. So all of these are really interesting things you can do. And the goal of all of these things, again, I want to keep going back, is to make our human lives easier. At the end of the day, that's really what all of this boils down to, is so that our human lives are easier, so we can focus on the creative aspects of things, not just on the routine grunt work. So we can focus on what humans do best, which is creating new stuff, making pleasure. Really, the human objective on planet Earth, right, is really is our charter. Our charter is manufacturing pleasure. Right? Now, I don't mean pleasure in the gross sense of the term, right? So I mean that deep-seated satisfaction and happiness that comes. Not from ordinary, satisfaction of biological desires, but that's what, because I think ultimately, this is my hypothesis, right? I don't know if we can devise a test to figure this out. Maybe we can do some soft tests like they do in soft sciences, right? But I think everything we do in life is basically motivated by our fundamental desire to be lazy, right? So and laziness is a good thing, right? Laziness doesn't mean, sitting around doing nothing at all and dozing off. And that's not the kind of laziness I mean, right? Because, dozing off or watching Netflix to the end of days to come, that is really not anyone's cup of tea, really. I mean, you could say, you could try it out, right? So right now, the Christmas holidays are coming up. So you got 10 to take 5 days out, right? 5 days out, and say you're not going to do any work anywhere, right? Because you're not enrolled in any courses at that time, and over the holidays. So between the 25th of December and the 1st of January, right? So to take those 5 days out and say, I'm not going to do anything constructive whatsoever, right? So I'm just going to sit around lazy. I'm going to chill for 5 days. I'm going to watch Netflix. I'm going to play Fortnite. I'm going to do this, that, do that. And I bet that during those 5 days, you're going to be extremely bored doing that, right? And you'll say, well, what is it that I can do that's actually creative? What is it that, so you want to create that kind. I don't know, there's no words in English that I can use for this, right? The bliss, maybe, I don't know, right? So you're being driven really by that inner thirst, and say, which is not going to be happy if you're just sitting on your butt, right? It's not going to be happy. You want to create stuff to make yourself to remind yourself, or to see that and enjoy that deep bliss again and again in the future. So you make something beautiful, you're really not making it for other people, really. So because, honestly, you make something beautiful and put it out there, how many people are going to come and watch it and like it? Even though it's useful and beautiful, you'll find that lots of people out there, even though they may watch it and secretly enjoy it, they're not going to go out of their way to tell you openly that they like it, right? Or even make a like, or say thank you. Most people are too fearful or insecure. I don't know, not insecure, but maybe they're too fearful or too busy, right? To even say thank you. Right. So if you share something beautiful or say something nice, right? Suppose you say someone has done something really nice. Giorgio, that was a fantastic thing. And, you guys come back and say, thank you for saying that, right? Thank you for appreciating my work. And I don't require you to say that for me, because I've already got my fill of happiness by watching you guys. So, so who do you benefit by thanking me? You don't benefit me. I don't care a shit, whether you thank me or not. I don't, right? But what matters to me is that it was useful and you got something out of it valuable, right? Something that will stick with you and improve your life. And I believe that, if I spend 100 seconds talking about it, maybe 2 seconds of those, 2 seconds, 1%, 1 second of those, it ends up being valuable to you. You take it away, and that's what makes my day. And every time after this class, I take away a belief, whether it's true or not, that has happened. Maybe 1 or 2 people, it made a difference in their lives, and they enjoyed it, and it was useful, right? So don't bank on external validation, right? External validation and people coming to tell you that you're doing something good, or I like it, or things, because at the you may find, the reason I'm bringing it up is because yesterday I had a one-on-one with a past student later in the evening, right? And wasn't talking about computer science or anything, and they were on their path to applying to companies and joining, and they wanted a conversation with me to talk about just, life matters, not about computer science per se. Although we talked a lot about computer science, but we talked about, general life matters and what is important and how to approach these interviews, what is the right mindset to have when you start working in a company, right? And how not to have any agendas, because, you'll see lots of people with agendas, right? Even people who come to help you, who, especially if you're a brilliant person, right? If you're not a brilliant person, maybe people will say, I don't want to help them. They're not going anywhere and I don't get anything out of it. Right? If you're a brilliant person, lots of people want to come and help you. Even people who haven't really gone ahead, even people who are not as brilliant as you, right? Especially people who are not as brilliant as you will come to help you and say, let me give you some advice, do this. Let me give you some advice, do that. Everybody's full of help, right? But think about it. Always put that in perspective. You shouldn't disregard their help, but think about it, put it in perspective. Has that person actually done that? right? Has that person really succeeded in finding their happiness by doing this, right? Or is this good advice? You use your good sense. You find in many cases, no, they're trying to help you. Maybe they think it's going to help. Maybe they just want your gratitude to say, well, I know this person is brilliant. I know this person is going to become, an earth-shaking. They're going to change the world in a fundamentally positive way. So it's good that I help them now, regardless of whether the help, ends up making a difference in their life or not. Later on, when they're the CEO of XYZ.com, which is ruling the world, I could say, back in the day, I helped that person. That's why they're so successful now, right? So, people get highs out of these things too. But at the end of the day, who is the person that digests that advice and makes it part of their life? It's you. So if you always follow your heart and your dream, but not in a bad way, right? Bad way meaning I can get pleasure out of that, but eventually it's going to cause some grief to other people. You'll find, track it down all the way. People say, well, I do get pleasure out of it, so I should do it, right? Even though it's going to cause grief to that person. But that's because they stop right there and say, well, I got pleasure out of it, I should do it. No, you take the long view and say, well, I got pleasure of it now, but what is total net, integrate it from 0 to 100 years, right? So when you do that kind of analysis and say, is that going to be useful to me in the long run? Most of the time you find no, absolutely. What is really powerful? What makes my life better? What is it that gives me what I had wanted in life all along? And you find that is, well, in my case anyway, so I can't speak for everyone. So you find that is something that does not depend on anyone else. Right? So from that perspective, I don't have to go asking or begging people for help. You can be in the service of no man, right? So anyone else, you look around, right? So the people who are in the service of other men, right? So they're on a salary, you may be a director, senior director, super director, whatever it is, but you're beholden to commands from other people saying, you got to do this, and you're always fearful saying, oh, did I impress that person? All that kind of shit gets in your way and, prevents you from doing a really good job, right? And so on the other hand, if you just basically evaluate everything and say, is this eventually going to be, useful for me to go where I want, that thing in my heart, which keeps, pressuring me, even if I'm sitting on my butt on the couch, eating ice cream and watching Netflix 24 hours a day. After a while, it just gets tedious and boring, and it's another show. They're all following pretty much the same path, right? So, I think there was a long time ago, I read a strip in a comic called Mad. And they took a story, I think it was Cinderella, Cinderella story, a fairy tale, and then they made some intelligent tweaks to it, right, here and there, and they turned that story into like 5 or 6 blockbuster movies that were playing right then, right? So they said it takes one story and just take a few things, change it here and there, and then it becomes a brand new story. And that that really is what you'll see when you look at, after watching 1,000 movies, you'll see you're looking for something different because that I've seen that already. And then eventually you get bored with everything because you've been there and done it. And you see all these other people, they're still, going after those goals. They're trying desperately to get to that point and see what you've already seen, right? But it's okay. Maybe you might also not have seen it. Right? This is pure chance or factors in your life that you had no control over that somehow managed to put that thing in front of your eyes and you saw it. I don't know, maybe call it divine grace if you believe in things like that, but somehow serendipitously, some things come together and you happen to find it. And you see a lot of people haven't found it, right? And they're looking, and you can say, well, this is what you can do, right? So, and then it's up to them. Whether they do it or not, it's up to them. But what you are after is hoping that, well, hopefully they have good sense. You have good sense in them so they can see, right? Without agendas, they can see what you tell them and look at it with an open mind. Then they'll see that it actually makes total sense. And that's what I should be doing. But on the other hand, many people will just look at what you say and say, oh, those are just students. Those are just students, young people at Foothill. They don't know what they're talking about. So I'm not even going to be thinking seriously about what you say. right? How many people have you met like that? I'm sure you've met people like that, right? There are people who won't even give you the time of day, not in that sense. They'll talk to you and be nice to you and all, but they won't really think seriously about what you say based on other external factors, right? So the whole idea of education, right, in Foothill, that's what we're focused on, right, is really equality for all. Don't we treat every student the same, no matter where you are, which part of the world you are, what color you are, what it doesn't matter. What matters is your genuine curiosity to know the world. How does the universe work? How do these amazing things come about, right? So that curiosity is what appeals to us as students, as teachers, because that's what we're looking for. Because if I get given a damp piece of coal and asked to light it, I'm going to say, oh gee, I got dried out first. It's what a real pain in the butt, right? But if someone gives me a hot piece of coal, right, preheated, right, all I need to do is blow on it and it'll just spark into flame, like oxygen, right? So everybody's going to be competing. Everybody at Foothill I know, right, all those teachers I know, the professors, they're going to be competing to grab that piece of coal because they're so hungry for knowledge, right? So all we need to do is just gently nudge you in the direction saying, hey, there is that incredible control structure out there that's going to do exactly what you want, but you better, and then you're all running towards it and getting it and fitting it into your own programs, trying to say, hey, oh my God, I just used that and I reduced my program from 25,000 lines to, 20 lines or something like that. And that pleasure is incredible. I think, and it's the same. It's the same. It doesn't have to be programming or these are programming or mathematics. It doesn't have to be, right? It can be anything. I'm not a sports guy. I don't even follow games. I don't know how these games work. But I'm pretty sure, coaches, right? Coaches in basketball. Actually, this is the only time or instructors in exercise or dance or singing. They all feel exactly the same way, right? There's sometimes you get a brilliant gemstone which is not yet polished, right? And then there's a lot of competition for that because we want these brilliant gemstones, and also we want these gemstones, after they've been polished, to know that they are gemstones, right? How many times have you come across a situation where the stuff, you're rock solid, you are brilliant, and you know that you are brilliant, and you explain something to someone and it basically falls flat because they don't understand it, right? Because they're not brilliant enough at that time in their lives to understand what you are describing to them, right? And so you think, but there's two things, there's two aspects to this, right? Either they could completely lose what you've said and say, well, that guy must be a dumbass, he doesn't know what he's talking about, right? So they completely dismiss you, or they could say, they could get halfway to what you're trying to explain, which has also happened to me a lot, right? So halfway, so they see that you're on to something, but they haven't really realized the full value of what you were trying to say, because that may take a long time and maybe life experiences and other factors. So so they say, wow, here we are playing around with scratched and rough glass and silicon dioxide crystals, but that guy has shown us how to make really crystal clear, sharp, shiny glass, right? But and they say, wow, you're absolutely fantastic, you know how to make shiny glass, right? But that also is a tragedy, right? Because that's not what you were showing them. You were actually showing them a gemstone, a diamond, because you have the brilliant diamond inside of you, and you show it to them and they say, wow, that's a really nice piece of glass, it's really worth something, I'm going to sell it off as glass, right? A shiny glass, from Corning, the latest research from Corning, and they sell it off. Easy to sell you because you are brilliant, but you're not being sold as a diamond, you're being sold as a piece of shiny glass. And lots of people are happy with that, because many people I know, right, many of my past students, they were really brilliant diamonds, gemstones, but they didn't know they were gemstones, and they didn't even believe they were gemstones, because in the environment they're in, I don't know, maybe it's a toxic environment with people around them, right? People around them constantly telling them, not explicitly, right, but sometimes it's implicit, sometimes it's just by way of advice. When someone gives you advice, You can tell from the underlying message in the advice saying what that person thinks of me. Do they think that I'm actually up to no good, or they don't think the idea is so valuable because they're giving me stuff to make the idea better, right? But all the while, they haven't really understood the real idea, right? They're commenting on some superficial aspects, trying to optimize the code without understanding the internals of the code, right? So they don't, and they're saying, well, I've looked at the superficial aspects and you need to change that. Well, you've seen all those, you know you don't need to change those things, but those are the easy problems. You can come back to the easy problems later, like Don Knuth said, right? So the premature optimization is the root of evil. So you don't want to do the premature optimization. You've thought about those things and you've done the hard job, really. The hard job is optimizing the internals and the guts of it, and you've done that already. But some superficial observer, right, some family member or someone who comes to help you, and says, oh yeah, I can help you. I can get a job at these great places, and talk to this person, talk to that person, and they'll give you a lot of, advice. Eventually, dead-end advice, right? It doesn't really go anywhere because everybody has their own agenda, and they'll give you advice, and unfortunately unfortunately, if you're surrounded by lots and lots of people that are like that, giving you kind of false advice, really false, good-meaning advice, I don't know, right? Eventually, even lies, even outright lies, as we all know, if you repeat it a sufficient number of times, people will start believing it as truth, right? 50% of America believes something today, which may not be the truth, right? And so the problem really, and the tragedy is that at your age, right, young college students at your age, you're very susceptible, not just to peer pressure amongst your classmates and everybody else that you talk to every day, but also amongst the people you interact with. And especially now that you're at home all the time, and you have, the only people you talk to are your relatives and your, family friends who come over and talk, and you got to be on your guard, right? Because you got to question really, what is the point of the advice that these people are giving me? Have those people actually succeeded? Ask yourself the question first, right? You filter all the advice out. Have those people actually succeeded in doing what they are asking me to do, right? And if not, right then your answer is right there, right? So you can accept their advice with a smiling face, but really in your mind, what that advice is worth, right? So you don't follow that and then burn yourself in the end, like they did, right? So at the end, what have they got to show? Right? They just, at the end of the day, they're just going around advising other people. So don't be in that category, but be in the category where you have knowledge that you want to share. Right? And then you're not telling anyone to do that. I'm just showing you, right? In my classes, it's very different from all the other classes you may have been in. I'm not telling you this is the way to do it. This is the way to do it. This is the way to program. You notice, right? If I do that, just point me out and tell me, hey, Anand, you told me that you're not going to tell me to do something and you're telling me to format code this way or that way, put a space there and so on. No, right? Every one of those is just a recommendation. Even, take all the recordings of our YouTube videos and I say, make a space there and brace to the next line and so on. I just say these are recommendations. You don't have to follow them, but that's the way I do it, right? So you do it, you'll find things as easy as it is for me. For me, I think it's pretty easy. Many things I do is easy because some of the habits that I picked up or trained myself to do may not be the same case for you, but you have one data point that at least one human has benefited from these programming idioms, right? So one human finds it easier to achieve things by following these practices. So from that perspective, you are welcome to heed my advice, right? Think about it and see if it helps you, rather than just follow what I say blindly. Never follow anyone blindly, right? So and I have to say this every lecture, really, because of your age, right? Because people tend to forget these things at your age. So does that make sense? Now we're at 8:30. I think let's see how many class students we. Oh yeah, okay. So we're back up to a full class. That's fantastic. I'm actually very pleased that you guys are all coming back, which also makes it easier for me, right? Because at the end of the quarter, when it comes time for me to award participation points, it's easier for me to, when I do the, collect the names and sort and things like that, I have a clear-cut distinction about how many points, rather than, like the current presidential race where, everybody's like that and I have to figure out, how to calculate the right values. So it's fantastic. I'm happy that everybody's here. And in fact, I'm happy that you're all coming, even though these lectures are optional, and you have the option of getting participation points just by participating in the forums. You don't have to participate in class. You don't have to come up here like Giorgio and all these other people. If you participate in the forums and ask questions and answer other people's questions, that also qualifies for participation points. So, so despite that, the fact that you're all coming to lectures and listening to me, babble on about nonsensical stuff, I'm very pleased. So I can just hope and expect that what I say is at least 2% valuable to you, right? Yeah, a lot of it is fluff and a lot of it is stories, obviously, right? That needs to be used to fill up the time and keep you engaged. But I hope that in every 100 minutes of my blabbering on, there's at least 2 minutes of useful stuff that you can take away, right? And when you find that, try to see if you can just mark it in the YouTube video and say, hey, that comment on it made about formatting, code, or dangling else's actually turns out to be useful, although it's not useful from the exam point of view or something else, but it's actually very useful from a programming point of view, because now with that suggestion, I can program this particular thing much easier, right? So you can say those things, because those are the things that actually help people, right? Or everything else is just filler material to keep you reined in, right? Because if I'll constantly talk about computer science and C++ and operators, after a while, I think I begin losing you guys, right? As it happens even in our classes, when in the middle of Giorgio's demo and I'm talking about this and Giorgio's fiddling with the code, and then I ask for suggestions and say, hey guys, can one of you tell me what we should do here? As like deafening silence right there. And then I'm just led to believe that when we start coding, you guys just disappear, or switch your mind off. And say, well, okay, well, we're not talking about stories now. We're talking about code, and obviously code I can pick up by reading the book, or online, go to some online Khan Academy lecture, and I can pick it up, and you're all gone, right? So you just leave the Zoom thing logged in. So I don't know, right? So that's why I don't know. Or maybe it's just part of my nature to just keep talking on and on about stuff. All right. So today, what I want to do is to take the code that we wrote last class and play with it a bit more. If you guys are okay with that, right? If you have other suggestions, I'm happy to listen to that and follow a different plan if you have other programs. But I'm thinking that in the absence of other suggestions, we'll take that program that who was the last person to code last class? Was it I think the first, the second, Flavio was second. Who was the first last class? Was it who came up on a screen first last class?
It was me, Rizzo.
Rizzo, yes, Laska, you brought Laska to class. Laska, the pet cow.
Yes.
Yeah.
Yes.
Okay. Yeah. So yeah, Rizzo and Flavio, and then one more person. I forget their name. Who was the third one to come on screen last class?
I think it
It
was
was me,
Bayo.
Bayel Astrbekov.
Oh, what was your name? Sorry.
Bayel.
Bael, that's right. Yeah, I forgot. Yeah, thank you. Yeah, you three came on. So what I'd like is for someone to pick up Bael's code, because Bael is the third person to come on. So he's got the latest copy of that code. So I'd like someone to pick up that code from Bael, and we'll take it from there. And what can we talk about today? I think we can talk about constructors. Yeah, we'll talk about constructors. And then we'll talk about static variables, right? Static members and constructors. Along the way, maybe we'll try some experiments to do with const. Actually, I haven't tried it myself. I was hoping to try it before class today, because yeah, someone raised this point. I was Andrew or Andy last class said, hey, how do we have a const member, a read-only member inside of a class? So I was thinking, so I didn't remember exactly how to do that. I knew it was a const qualifier somewhere, but I wanted to experiment a bit before class today, but I never got a chance to do that. So today we can actually experiment live in class with all of you, right? So we'll try and make some read-only variables inside a class, but certainly statics. We can do statics. And then, if time permits, we'll try and take that class, a pet class, and make it a bit more sophisticated, right? Add some more interesting things to it. I was thinking, if you guys are okay with it, I think we can insert an array inside that pet. Since Rizzo said, it has a a favorite food member, I think we could insert an array of food preferences. So array element 0 is the favorite food, right? Array element 1 is the next favorite food. And so maybe we can have, we come up with 5 or 10. Let's say 5, 5 choose 2. Yeah, 5 choose, what is 5 choose 2? So 5 times 4 over 2 is 10. 10 is it 5 choose 2 10? That's all? So you can only get 10 pairs out of 5 elements? I don't know. I think my calculation, n times n minus 1 over 2, right? That's the number of pairs you can get. N choose 2. What's n times n plus 1 over 2? I got it. Oh my gosh, this is fundamental stuff. I got to work it out. But anyway, we'll figure it out, right? So n times n minus 1 over 2. Yeah, okay, thank you, Augie. Right? So 5 times 4 over 2, that's 10. So you only get 10 pairs out of 5 items. Yeah, I think that's okay. That's okay. All right. So let's take 5 food items. And then in the constructor, let's shuffle it. Yeah, okay. I see. We're getting rid of the ordering, so it's not permutations. So you divide by n times. All right. So we can say this pet Lasco likes 5 different food items, right? Meat, cabbage, lettuce, I don't know, steak or something like that. You got 5 items, but it prefers them in a particular order, right? Maybe it prefers meat the most and lettuce the least, right? But we don't know, right? Because we're going to make the thing shuffle and choose an order randomly. Anyway, this is just an idea I thought off the head, so I haven't actually tried it out. So maybe I think it should work, but if it doesn't work, we'll find out, right? We'll make some changes along the way. And then we could turn this whole thing into a kind of game where there's an order of food items that only Alaska knows, right? Alaska knows what it prefers and what it doesn't prefer, because it's an array that's been shuffled internally. And then our job as the owner of Alaska is to figure out which item it likes the most, right? By asking certain targeted questions. And we could say, given meat and lettuce, which would you take, right? And say, I want meat, right? And you can figure that out, right? Alaska knows which one it wants because it has the array that it can look at. So you got one question answered, right? And then you can ask another question. Between cabbage and lettuce, which one do you prefer? Right? And then you say, oh, between cabbage and actually, I hate both of them. But if I had to force me to eat, I'll eat the cabbage, not the lettuce, right? Or something like that. So you got one more answer, and then the game becomes a challenge where you have to ask these questions and figure out the exact ordering. Right. And in the end, you would say, I figured out your complete preference list, right? So you like meat the most, and then steak next, and so on. So you say, this is my mental model of your mental model, right? My mental model of what you want. And you say, this is the order. And then if it's right, Alaska will say, yay, you know me. So I'm going to be, I give myself to you. You can be my owner because you know exactly what I want. Okay. So it'll be a nice little game. And obviously, if you only have 5 items, that's great, because in 10 chances, you can absolutely guarantee, right? In 10 chances, you can find out. Well, no, actually, it's not 10, right? This is 5, n times n minus 2. Yeah, okay. Yeah, I think in 10 questions, you can absolutely get the right order of those food items to get rid of pairing. So yeah. So does that sound like a plan? We can do that. I think it's feasible, right? I think it's feasible to do within an hour. Yeah, we got an hour, less than an hour left, I think. Well, yeah, I think we got an hour. So we can do that. I think it's eminently feasible. I think we should be able to complete it too, and even play a game, and you play it too. Do we do that, or we'll see. All right. If not today, we'll complete it on Tuesday, because next week is supposed to be the class when I talk about arrays inside of objects and how to do these things. And if we start doing that already today, you get the entire weekend to play with it and tweak it and come up with more sophisticated versions of the same game. So all those interesting things will be possible if we try and at least make a headway into into that problem today. But at the very least, we'll try and go in that direction if possible, unless one of you has a better idea, right? So this is just one idea I toss out. And like I said before, this is just a baseline idea. right? Baseline meaning if nobody has a better idea, they will fall back on this. And if you have a better idea to try, by all means, right? It should be comparable in the level of difficulty to what I just talked about. And then we'll take that and run with it. Otherwise, this is what we'll do. Is that okay with you guys? If that is okay, I'd like someone who's never been on stage before, right? Someone who has never danced. So I would like them to be brave, and come up here, put yourself out there, take it and take the screen and run with it, right? So this is your chance. And always keep in mind, and again, I say this every class, because this just needs to be a mantra. It needs to be a mantra that is playing out in your head every single time, every single second. You should be telling yourself, no fear, don't fear, because fear is the only thing that holds you back, right? It's from achieving your full potential, from being your own brilliant self. Every single day, right? Every single day, I see brilliant people. I talk to brilliant. Last evening, I spoke to a really, really brilliant person. And I can see that this brilliant person is living with handcuffs, right? Not in a jail, but because here today we pride ourselves in being in a free country, right? We are liberal, free. We have the freedom to express our minds, but that is not true. That is not true. America, the Western world, anywhere you take, right? People are not living in a free world. If they're living in handcuffs, in fetters, in jails and cages, because they're afraid to speak their mind because of what other people will think about them, right? But why do you give a shit about those things, right? Unless they're going to come and hit you for believing something, or take away your food, or deny you your survival requirements. The 3 F's of survival, evolution. What are the 3 F's, right? The 3 F's of what contributing to successful survival of the species. The 3 F's: fighting, feeding, reproduction, right? So those are 3 F's. So don't if someone is going to come and take away one of your fundamental requirements for living, okay, then you need to be concerned, right? If someone is just going to think badly of you for saying something, why do you give a shit, right? Because most of the time, those people don't even know. Maybe they're not even brilliant enough to think through like you have to what ultimately matters, or what are you trying to get at, right? Maybe they're just after some superficial goal, and they think, doing what they did doesn't take me to that superficial goal, right? So I'm not going to do it. And that person is a stupid dick ass for doing that, right? So, but they don't know, because they're going towards a superficial goal where you're actually going on a different route that gets you to the end product sooner, quicker, right? But they don't know. And so don't, but on the other hand, if they say to you, right, if they just don't think badly of you, but they tell you, why are you doing that? If you do it, isn't it easier to get here? That is a sign of a healthy relationship, right? So even in a company, when you start working, right? When you start working, you do something, and there will be people who come and look at your work, and they see that it's an inferior way to do it. And they say, that person, I don't know, they usually do a shoddy job, but let them finish it, and then I'll tidy it up and fix it up, right? So they form these opinions. But on the other hand, you see other people, right, who come and ask you questions. You look at your code and say, hey, why did you do it that way? But if you do it that way, doesn't it add a 2x overhead to your already linear function or something like that, right? And then you start thinking about it, and then you could brainstorm with them and say, yeah, man, I'm totally right. Yeah, I didn't look at that. How can I change that? Actually, adding that variable to the counter inside the loop. I think that's really what is causing this algorithm to underperform. But I can see that it's a idempotent operation if I move it out, right? So maybe sometimes you can just take the variable out of the loop, multiply it by some quantity, and add it, and you just took out. Like if that loop is supposed to iterate like 2 billion times, and taking one statement out of it, you just took out 2 billion instruction pods, right? So sequences of instructions taken out. It actually makes a significant speed in your, right? So, and then you brainstorm collectively, and then two minds that are not agendized, right? If you have someone with an agenda, I need to somehow prove that I am better than that person. I need to somehow get that promotion, that both of us are competing towards. People have agendas, or go nowhere with them, right? So, but you have to be very good at identifying people that don't have agendas, I think I said, right? And work with them. You'll find that your own knowledge of the skill that you're trying to pick up just exponentially, the rate at which you pick up skills, that just grows exponentially. You learn faster by being in the midst of positive people, right? So if you find yourself in the midst of negative people who don't think much of your work, who are not able to appreciate your work, who are criticizing you and saying this is a wrong way to do it, instead of telling you the right way, or nudging you towards the right way, keep on telling you the wrong way, or not even, right? So those are people you should need to move away from, at least mentally. Maybe you're not able to move away from them physically, but mentally at least you should build a wall, right? Build a wall to say, well, you can say what you want, but I'm going to listen to you from the other side of the wall, where I'm safe, and then evaluate it to say that, is it actually going to work? Right? And if it works, I'll try it out. If it doesn't, I won't try it out. But because there's this wall, I can be sure that I can be free of repercussions, right? Because some people are offended if you don't follow their advice, stupid people are offended. No, again, not stupid, but uninformed people, right? Uninformed people will be offended if you don't follow their advice. I don't care if you don't follow my advice, because I am informed with the data from several quarters where I've taught before. I know that many times I tell students to do something and they don't do it, right? I don't do it, and I know that they don't do it because of 1,000,001 reasons that I don't even have visibility into, right? You may be doing some totally stupid thing, but maybe that it's stupid, right? And you still do it because you have these factors that you need to take care of. That's perfectly fine, right? It's perfectly fine. As long as you know where you're going, that's fine, right? If you know what you're going, you can do incorrect things, not incorrect things that affect other people, but to get to where you're going, you can do. So that's why in code you'll often see we talk about good practices, right? We see ways in which you can structure loops and these things which are slightly out of the ordinary, right? So and I'm pretty sure those of you who've taken computer science or programming classes or other professors, I'm sure you've come across some professor somewhere who says, no, you should never use break statements, or you should never use continuous statements, or you should never, right? Even go to, right? Even I say don't use go to statements willy-nilly, right? But it is still possible to write very, very crisp, crystal clear code, even using go to statements, right? Say Don Knuth or someone, right? I think if you take the fundamental algorithms, the book, right? You see many of the programs that he's written in Mix, right? As an assembler. Mix is a theoretical assembler language, I think. I don't think there's actually an assembler for Mix, right? Knuth created that so that he can, back in the time when he wrote fundamental algorithms, I don't think there was any real compiler. C did not exist, and I think he said, I have all these sophisticated, really cool algorithms that I want to teach everybody who wants to learn. Unfortunately, I can't teach that in ones and zeros in binary, right? Because that was a time when Knuth and all these people came up with these beautiful algorithms, and he said, I can't teach this in binary. I can teach it in English by saying this is what you do if you have this object that's linked and so on, right? That's again, going to the other extreme, which is painful. So what I need is some kind of intermediate where it's not binary and it's not English, but something that is structured in just enough to be able to understand the logic, right? But at the same time, it is not as loose as English, right? It has enough disambiguation built into it so that the compiler or an automaton, a machine that looks at that code, can find out precisely what it needs to do, right? And I think that was the motivation for manufacturing in his mind this assembler-like language, which he used as a medium for describing his language. Ever since then, we have millions of assemblers, millions of, exaggerating here, but real compilers. Now you can pretty much today, you can write a computer program as though it's an English sentence, right? Now C, which is a very early language, you can see that, even in C, you can see that we're writing programs that are pretty much readable by humans, right? It's a while not done, and you use these words. And so you can imagine how some of the more sophisticated languages that we have today, than C, right? This is higher level languages than C. You can imagine how much closer to English they're getting, right? So eventually, I think we are getting to a stage where we'll be able to use AI and machine learning to discover programmer intent unambiguously, right? There may be ambiguity, but it could easily, Alexa or Siri can easily correct the ambiguity by asking a very focused question, right? Where there's ambiguity. And it's easy to determine the points using a sophisticated model. You can say and disambiguate the programmer intent and stitch together a program. So we are marching very quickly towards a time when we don't have to cut the code, the nitty-gritty details of the code ourselves, but the compiler the computer can do it, because I can basically talk to Alexa or Siri or Google now, right? And I can say, I want to write a program, open up an editor and code up Dijkstra's algorithm there, and it should take a graph as passed in as a reference parameter, but I want to make a few tweaks, right? Maybe where it inserts into a priority queue, insert it into a regular queue, right? And that should all be possible to do just using voice. As that means I can just be sitting on my couch, hands-free, right? Hands-free, and be talking and programming with my code on the TV, right? In the living room. I can look at the code in large font, right? And I could be coding by voice. Even now you can code in voice, but you have to painfully spell out each token, right? This is real pain. This is, I won't do it right now, right? But in the near future, I'd be able to do it comfortably, right? Without having to strain my vocal cords, talking to the system as though I'm talking to a machine, right? And say, code this, yeah, okay, replace that block, okay, split that into a different file, right? Now compile it, let's see what the output is. Oh, I want to make some data, create some data, right? And in fact, I want to manufacture some data which has 2% noise, right? And use a Gaussian distribution for that variable. So something like that, I can say that and then create a data set and throw it at the algorithm, which was also coded up by a machine. Right, so we're getting there, and very soon we'll be in a place. Oh yeah, but going back to my hypothesis, that we're lazy people, that we all want all the routine work. Anything that can be done without thinking, we want it to be done without thinking, so that we can use our thinking to do something that is really worthwhile to us, right? Everything we do, that's what we do it for, right? Everything we do, we do so that we can create more opportunities for us to get more out of life. What do we get more out of life? That bliss, right? So that's what we're going for. All right, so why hasn't anyone picked up the screen and shared? I'm going to keep on talking until someone picks up the screen and opens up Augie's code, not Augie's code. Bile, right? Momo, thank you. All right, thank you. Great. Let's go. All right, so here, yeah, all right, I need to move this window to the side, and somehow it moved over. What's going on? I can't move. Oh, oh, geez. Okay. Yeah, I'm not sure. I'm not looking at my desktop. I'm looking at your desktop, and I believe you're on a Mac and probably using the exact same screen background as I am. So when you took over the screen, I couldn't see any difference. But my window moved over to the side. And
do you need me to stop sharing my screen?
No, totally.
Okay.
Your screen is the one that should be shared. And I was confused because I have I think the same screen background as yours.
Gotcha.
Yeah, and then I thought, what the hell happened there? All right. Okay. So is it possible for you to move? Actually, I'll move. All right. I'll move to the side. Because the iMac screen is bigger, your thing moved all the way to the right. And okay, now I can see it. It's in front of me. All right. So here we go. So here, does anybody have any questions about this code before we move on to talking more about it? So the first thing I'd like to do is create what is called a constructor. A constructor, and I'll talk a bit about the constructor too, because here on line 29, okay, yeah, line 29, not 29, sorry, 31, you say that I want a pet, and I'm going to call it my pet, right? And then how did you get a pet? So what the compiler did at that point was say, oh, I need to create a pet. And there is a template for creating a pet right up there, right? All right, lines 5 to 28 is 28, right? No, 20. Wow. Yeah. Okay. Line. Yeah. That is the pet constructor. Thank you for highlighting that, Momo. Right. So it knows how it creates it for you, and what the process of creation is that it's not just going to look at the template and do it every time. What happens is that it is a very streamlined process. Every time you define a class, the compiler creates something if you didn't create it yourself, right? So you can create it yourself. The compiler creates something called a constructor. A constructor, like the word construct means, is going to construct an object of that type, right? So the constructor is a function, is a method that you can actually create yourself and attach it to the pet object. If you create your own constructor and attach it to the pet object, that means when you create an object here on line 31, when you create an object, it's not going to invoke the default constructor. Because if you don't create a constructor, the compiler will create a constructor anyway, right? A freebie, you get a freebie constructor that's just going to take all the members the object has and give them default values, right? Actually, we found out last class wasn't default, right? This is an integer variable. The integer member age didn't have 0. 0 is the default for integers, right? It had some junk value in it. So it gives you the locations, right? It sets apart the space for the object. So you get a freebie constructor. It's called a freebie constructor. It's given to you by default. However, you're not stuck with it. You can say that, well, you know, my constructor, my object, when it comes into existence, needs to do a bit more than just have empty spaces for its parts, right? In fact, it needs to do, as soon as it comes into being, it needs to do some other additional things. It needs to announce to the electoral college or something like that, right? It needs to announce, send a message saying, I have just come alive, increase your citizenship count, or your population count, increase your population count by 1. Right? Or it might say, I've just come alive. Now I have these integer variables. I need to set default values in them. I have a name. I need to set my own name. All these things, right? Those things are not given to you for free by the compiler. All the compiler will say is that I'll give you an object with, you know, empty spaces. That, you know, I'll give you an empty box. But sometimes you don't want an empty box. When as soon as what you want really is go to line number 31 and hit enter. Right, enter. What you want really is a function like a type in my pet, my underscore pet, yeah, dot initialize, right, open close parentheses. Right, so that's really what you want, isn't it? So actually, let me pull up the chat window. I can't see what you guys are talking, and you guys are also silent, right? So you got to let me pull up the chat window, because the chat window keeps going back, right? So you guys have to talk, yeah, so the last message I have is from Momo saying he'll run the code. So everybody should just volunteer and chat, right? Hit the spacebar and say, right, I don't know if this is working at all. Can everybody, starting with, you know, Augie, hit the spacebar and say, yes, I can talk, right? Yes, I can talk, or, you know, yes, my microphone is working, or something like that. Just hit the spacebar and say, wait until one person has done it, and say, we'll see if everybody just goes at the same time or waits for one person to complete before they say, right? Hit the spacebar, say, I can talk.
Hello.
I can talk.
I can talk.
You can talk.
I can talk.
Okay. So it looks like you can talk. All right, good. That means that when you want to chime in,
I can talk.
Thank you. And you should do that, right? Even when I'm talking, you should be able to hit the spacebar and say whatever you want. That's very important, because I want to make sure that, unlike in a phone, right? When you're on a phone and you're talking to someone, sometimes because of the, you know, channel capacity maximization, I guess, right? They shut off a duplex, and you can't even hear what the other person is saying when the, you know, system is piping voice from you to them, right? So I want to make sure that doesn't happen with Zoom for bandwidth purposes, right? So you should be able to interrupt me when I'm talking and do that. Okay, so that's the function we want. We want, as soon as a pet is created, we want to run a function that'll go and initialize it. And inside the initialize function, maybe you do all your fancy things, right? You increase the population count somewhere else, and you set the name of the pet, you set the age, and all those things you do in initialize, right? So that's what we want. In C++, all of that can be done in the constructor, right? There's a special function called the constructor, which you can force this compiler to call your function when a pet is initialized. So let's go ahead and create a constructor. Now the constructor has a special declaration. That's the only function. There's 2 functions, right? The 2 functions. It has a special declaration. In that, the constructor does not return a value, and And many functions don't return a value. But the other thing is that even though it doesn't return a value, you don't qualify the constructor name with a void return type at the beginning, right? Even though it's void, you don't qualify it void. That's how the compiler can also tell that it's a constructor, and if it follows certain guidelines.
So what's the other special function?
It's a destructor.
Oh, that's
a constructor and destructor. So they both don't have return types. And we'll talk about both. Funnily enough, I looked at the syllabus and then I look at the CID, the descriptors, the state level descriptors for this course, the CS2A, and there is no mention of destructors. Constructors and destructors. There's no explicit mention of this. On the other hand, they have an explicit mention of file streams and so on. And I think we actually have an input. We have an opportunity to chime in on the CID, the state level descriptors, and whether maybe we'll use maybe we'll chime in with our input this time and say, hey, we need make some tweaks here. This is more important. That's less important. And then maybe in a couple of years we'll have a new CID descriptor. But I'm not talking about file descriptors. File input streams. You can find out all that by yourself. When you can handle string streams, and you can handle standard input streams. File streams, just 1 or 2 lines you need to master after that, right? So the constructor is what we want to create. So we don't have a method called pet.initialize, right? So you can get rid of the line now. So we'll go ahead and create a constructor. Okay. So now go up to under the public declaration in your class. Yeah, hit enter, and by convention, the constructor is usually the first method people will declare, right? And it's usually followed by the destructor also, but right now we'll just do the constructor. Okay, yeah. So do say pet, capital pet, yeah, and then open close parentheses. Okay, semicolon. Right. So what that means is that can you see that it's a really freaky and different looking signature there? It doesn't have parameters. It's the same, right? Parameters, constructors can also take parameters, but in terms of return value and the name of the function, right? The function name is the same as the name of the class, pet, right? And it doesn't return a value, so it's actually special. So that is a signal to you, right? Is a constructor. Now that method is what we want to implement. So now let's define it out of line, right? Let's not do it in line. You can also do it in line, right? But let's do it out of line. So go after the class, go to the line 22 and hit enter, right? Yeah, okay. And you give yourself another blank line there, so give some space. Okay, go back to 23. Right, now you can define the pet constructor. So, and you define the pet constructor. You declared it on line 13, you're going to define it here. Okay, so you say pet, : pet. Yeah, pet. Okay, open, close. And then, and give it an empty body, you can fill it in. Yeah. Yeah. Oh, are you waiting for me to fill it in? Okay. Now, right. So let's just say cout constructor was called. Right? And I usually have a space before the brace too, but because you have a space before all the other braces, yeah, in that program. So after pet, you.
Oh, I see what you mean. Right here.
Great. Okay. So end line, and then let's run it. Let's let's make sure on line 37. Say cout a pet has been constructed. Yeah, okay, enter. All right, enter. One of the tricks that I employ when I'm coding is sometimes, when you're coding, every time you're coding, you're constantly experimenting, right? Because when you're coding and you want to know, oh, I want to do that, but does it work at all? So you basically just do it really quickly and find out, compile and run it and see if it works. And then if it works, you can get rid of, and simple. So what I do is when I have lines like line 37, then when you're coding a big program, you'll have lots of lines like that. They're called diagnostic lines. Diagnostic meaning, you stick those lines in there and then you run it and you see the output and say, okay, right? So I tag those lines at the end of the line. I tag it with 4 forward slash. You don't have to do it, right? This is just a trick for you to remember. You can try it now and you can get rid of it later, right? At the end, I tag it with 4 forward slashes at the end of the endl on 37.
Okay, and then you do forward slashes.
4 forward slashes, anything, you can tag it with anything you want. And in fact, many IDEs also have special tags like to-do items and so on, right? So this way, what I do is before, when my program is done, before I release it to the public, I just do a once over in my editor, and I just look for the four forward slashes in the editor, which is search for the forward. It's easier, right? And your cursor goes there, and you just go to the beginning and delete those lines, nix all those lines, and then the program is ready. And
Gotcha.
so I think in Visual Studio and some of the programming environments, you can also use hash defines, hash define if debug, include the line in the code, and then hash end if. I've tried that. And very soon your code becomes very cluttered and untidy, and it's a sight to look at, right? It's awful. So I don't like that so much. But you have two options. You can do it that way or this way or some other way you like. This way I can just go ahead and clean it all up at the end, and the code looks beautiful. Okay, all right. So let's compile and run it and look at the output. Let's compile.
I can't like compile and run it. It looks like I basically just saved the file that Bio gave me, and then I opened it with CLion. I don't know what it's
Bio.
missing.
Bio, are you there?
Yes, I'm here.
Yeah. Okay. So what's going on? He says he can't compile the code. But so what's going on? So compile it and let's see the output. Compile it and let's see the console where you're compiling. I can't see the console right now. I can't see what's going on when you try and compile it.
Can you see now? Like it's this build.
I can't. No, I can't see the console. Where's your console?
It'll show up on the bottom.
Oh,
like,
the bottom. Oh, yeah. Okay. Yeah. Okay. I see it now. All right. Compile it.
Do I just write?
Oh, I see. You're not getting the compiler line at all.
Yeah.
Oh, yeah. Of course, this is a different replete, right? So, all right, let's try this. Okay, go to the beginning of the line. I hope this is a regular terminal. No, not there. The yellow arrow you got on the console. Go to the beginning. Hit Control A, Control A, Control A.
Control A.
Yeah.
Control A doesn't do anything.
Ah, geez. Okay.
Command A.
Back arrow. Go to the beginning. Back arrow. Go to the beginning of the line. Oh, I see. This is your compsci.cpp is your prompt. Okay, I thought that was something you typed in. All right, yeah, okay. And it looks like you're on a Unix prompt. Okay, try just hit G++ and hit enter.
G++.
Enter. Great. Okay, you actually do have it. Okay, so yeah, let's just compile it by hand. Okay, it's not getting auto-filled in for you. Okay, type in G++.
G++.
-o main or something, or -o compsci. You call it -o main. -o, not /o. Right? -o space. Give it a name. Main. Call it main. Yeah. Okay. Space. Compsci.cpp.
Compsci.cpp.
Hit tab. No. Get rid of the .cpp and hit tab. I want to see if it auto completes.
Nope.
Okay. All right. .cpp.
Yep. Nope. .cpp.
Enter. How come you're not there? ls-l? ls-l? ls space -l? How come you don't have anything here? Where is this file?
So it's on my, so Bael shared it on the chat. I basically copied it and pasted it on my desktop, and then I opened with CLion.
Okay, hey, one of you guys, don't open it. Oh, I see. This entire file is on your desktop. It's not.
Correct.
You're not editing in Replete. Okay, all right. So in that case, do this. Okay, but after this, your desktop is going to be cluttered. You need to clean up and also share the code online. Okay, Momo.
You can just copy and paste it on Replete.
Should I do that?
Yeah, do that. I think it's easier.
Okay.
Not easier. You can also do it on your desktop. I can show you how to do it. All you need to do is change into your desktop. You can do cd /desktop will just take you there. All right, just go to Replete. In fact, you don't have to copy and paste the code. Just click on Bael's link. It should take you to that code. I'm pretty sure it's saved on Replete. Yes?
No, actually, it's a file. It's not a link.
Oh, I thought it was an online coding environment.
I think he copied and pasted onto a file.
No, but I'm saying that even though he may have done that, the code that we worked on, which was in there, should still be there.
Yeah, I don't know if anyone shared that link with me.
Oh, I see. Got it. Okay, so the link is lost. It's a lost point.
Kinda,
okay.
Yeah.
All right. So
yeah.
compile it here in Replete. Oh, geez. Yeah, it's funny. I'm trying to move your windows because it looks just like my screen. I'm trying to move these windows. I'm thinking, oh, why is my trackpad not linked, connected? And it's your screen. And of course, I can move my chat window, which is covering it up.
So I don't think we have returns for the set functions because we made them Boolean returns, but then we didn't actually change them except for the set name.
Oh, yeah. Okay. Can someone do that really quickly? So I'm not going to talk you through this. I would really like someone else to talk you through converting the two remaining set functions into the one we have. Actually, can you widen your window a bit so that the code doesn't wrap on to two lines?
The REPL one.
Yeah, I think
Does that look better?
I think that looks better. Yeah, if I remember correctly, I think your setters.
I already have one of
Wait,
them
this
there.
is not this is
So
not the most recent code. Where did you get this code from? Because I'm pretty sure we progressed far beyond this at the end of last class. Because I remember we moved the setter out to be an out of line method.
it is an out of line method,
Where is it? I don't see it.
just below pet.
Oh yeah, okay. We did set name. I was looking at set favorite food or something else. Yeah, okay. Make them all out of line and just along the same model as set name. Is someone else please talk him through this? I want to see how Momo's doing, as well as how you're talking him through it, because that gives me a really good idea of where to focus on when I re-enter. So can someone please volunteer to talk Momo through the code as he's going to change the other two setters?
I mean, I could do it, I guess.
Yeah, okay. Who is this?
Augie?
Augie, yeah, totally,
Yeah.
totally. Go for it. Yeah. Hey, Momo, Augie and you are going to complete up this thing, and then we'll do the rest of the constructor stuff we talked about.
All right, sounds good.
So essentially from what it looks like, I mean, we could do it out of line on the outside there, like the other ones, which I guess we should probably do for consistency.
Sure.
Who are you asking, me or Momo?
I'm sort of asking both of you, but
No. Just ask Momo. Just ask Momo, because it is you're calling, not the shots, but you're making the suggestions, and Momo is can chime in and say yes, no, or whatever, right? So you guys do it. I'll just watch, right? I deserve some
Alright.
entertainment too, right? I'm here entertaining you all the time, so I'm going to be entertained now.
so we could also do it in the actual class definition as well if you want.
Sure. Augie, you kind of like cut off.
Sorry.
No worries. So I need to write a return for the setters for favorite food and age, basically.
I mean, essentially, we're going to copy what the thing in the set name down below is doing, which is we're checking to see if it's a null value and then returning false if it is, and otherwise we're returning true and setting the name.
Okay, so we just have to make two more like bool functions, right? Is that what you're trying to say? Like pet, set favorite food.
We also would have to remove the definitions up above and
Oh,
do
yeah.
the same thing where it's just
Yeah,
like
yeah.
the inputs in a parenthesis.
I kind of remember from yesterday. Favorite food. Set favorite. Oh, why is it red? String. Favorite food. Okay, and then so if the favorite food equals a blank, would that make sense?
Well, it would,
favorite
since
food.
we're doing favorite food here, it would still be favorite food.
Yeah, okay, I see what's going on. And then
But I think we could change it to the favorite food. Otherwise, we have to use this dot favorite food, right? Otherwise, it'll not understand it. I don't think. Maybe
yeah,
it will.
that makes sense. Yeah. So let's just keep it as the same favorite food because it's in the
And it's
parameter.
comparison, so we're doing double equals.
Oh yeah, good point. Double equals. Return false. And then favorite. Okay, let's see. What is it? So what should it return? Okay, wait. So in this in the first example of set name, we have name equals the name, and I get like, where did this variable name come from?
That's the variable name inside the pet class.
Ah, gotcha.
So
Okay.
that's what we're actually setting with this.
So
We
in
use
our
this
case,
dot favorite food because we have a favorite food variable in the function, I think.
like that,
Yeah.
return true.
We need to set it though. We need to set this dot favorite food equals favorite food.
Ah, okay. So favorite food
No, the other way around.
Equals favorite food.
And I think that's good.
We just have to change this to just we can delete that, right? I believe.
Yeah, and just replace it with a semicolon. Because we have the definition later.
Okay, and then we do that again for set age.
I don't want to cut you guys off, but I think instead of doing this dot favorite food, we should do this.
Oh yeah, it's the
favorite
arrow.
food.
It's this arrow favorite food.
Like that?
Yes.
Yeah, like that.
Cool.
Squiggly. I don't know why.
I
it's
think
squiggly.
we haven't done.
Oh,
I think
no.
that's
There it is.
int age. Yes, that's why. We want like a space after. Okay, cool. And then if age equals blank.
It's
No.
not a string, so it would be just
Oh.
a 0.
Shoot, you're right. Yep. That okay. Return.
You could have a 0 years old pet, right?
That is
I
true.
mean, I guess you could. So what would we have it be is the no value?
Like less than 0.
I guess that makes sense. You
Um.
can't have a negative aged pet.
Yeah. Okay, and now we just do the same thing with the this age equals age,
Yeah, I think so.
and then return true. Cool. I don't know why this is. Oh yeah, maybe it was because of that. All right, cool. Cosmetically, it's a little bit iffy, but I think that's just because.
No, why do you say it's cosmetically iffy?
Because
We're using a different convention for the first one than the second one. We might want to replace
Oh,
the
yeah.
name and then change the name there to this arrow name. Oh, and also the number of indentations.
yeah, it's kind of bothering me. Okay, so this name equals the name. Look good?
Yeah. I mean,
Alright,
we could
cool.
change the name to just name in all the cases where it's the name, but
Oh yeah.
you don't have to delete the whole thing. You just have to delete the
the
underscore.
underscore, yeah. Because we already kind of declared that. Because we declared name when we made the pet class.
Yeah, but then this would be a different name, so we have to use this arrow name, but we're using this arrow name in all the other ones, so it kind of makes more sense to just do it the same way.
This arrow just means like it's selecting whatever was in this parameter, right?
No.
Like when,
No,
oh,
it means it's taking the pointer for the value at the class object, I think. That was not explained well, but basically it's
okay.
taking
So, can I chime in? So yeah, what Augie's saying is that the parameter name is different from the member name inside of the pet object.
Like so the parameter name is going to be different from the name we defined in line 7.
Yes.
Gotcha.
Yes.
And so this pointer name is referring to like the pointer address of the name that we declared in the class object.
Right.
for
Except
the
it's not the
specific
pointer address.
object
We're
that
referring to that. Yeah.
It's pointing to that,
Yeah.
like not the address.
Right. Is referring to that, not pointing to that.
It's referring. Gotcha.
Yeah. Because pointing means it's an address, and
Mhm.
referring means it is actually that value.
Oh, like the content, like
Mhm.
the content of at that address. Okay, cool. That makes sense. So we're basically getting this parameter of name, checking if it's blank. If it is, return false. If it's not blank, then whatever we were given, the parameter is gonna overwrite what was like the blank, like the content of the name we declared in the object.
Yeah.
Yeah.
Okay, cool. All right, should we try running it?
Yeah, totally. It looks good. There you go. Yeah. So you see that that line, constructor was called, and immediately a pet has been constructed, right? So you know exactly where it was. So line 50, line 51, right? Comes out a pet has been constructed after the constructor was invoked, because a pet has been constructed came out of the constructor, and then a pet has been constructed came out of main, right? So at the time of construction, your constructor was called. Does that make sense? So it's very important to know exactly when a constructor gets called, because sometimes you may not have a constructor, and the implicit constructor given to you for free by the compiler, that gets called too, right? So, but it's important to keep in mind that the constructor is a piece of code that will get invoked every time an object is created. Whether you define the constructor yourself or not, the constructor would get called.
So basically, when we run it, it's
Mhm.
gonna run through our main, and then because so line 50 is gonna like basically kind of initializes this whole stuff up here, which is why we got constructor was called.
No, it doesn't. And that's not what it initializes. It goes further up. It initializes further up, further up. Yeah, this object, right?
So it initializes this stuff.
Yeah, it initializes an object of that class, because that itself is not an object. That's just a blueprint for making an object. Yes.
Yeah. Mhm.
So it initializes whatever object was manufactured using that blueprint.
Then how does it know to see out constructor was called? I don't like, how did
Because
this get?
that function is run when it's initialized. That's the
Right.
That's
part
like the
of
definition.
initialization.
Okay.
It's not the definition. It's the well, it's the constructor, but
So this
that's
this
run
format.
when an object
it
is
is a
made. That's
definition of
run
the
as
constructor,
part
yeah.
of it.
Okay, so this format means that like it was constructed like this, calling this when the compiler runs this, when it sees this, I guess, when it sees this pet : pet.
Pet : just means it's within the class pet.
Mhm.
So it's just the class name, open parentheses, close parentheses, is the constructor.
So what Augie is saying is that on line 23, that is basically you're defining a function, and the pet : means take this function and attach it to the pet class,
Ah.
right?
Mhm.
And the fact that it has the same name, this function has the same name as the class itself, pet and pet, right? It means that this is a constructor. It's a special function that is invoked every time an object is created of that class.
Gotcha.
So in your main, I think it's line 51. Is it 51? Yeah, line 50, right? In line 50 in main, that's where you're actually making the object. Until then, your pet doesn't exist. You only have a blueprint for how to create a pet. Your pet itself doesn't exist, right? Until line 50 is executed, you don't have a pet. Are we together so far? You
Yep.
have the the instructions, you have the blueprint, the template for creating a pet, but you actually never actually created a pet, right? It's a very important distinction to keep in mind, that you never actually create. You don't have a pet until you execute line 50. You don't have a pet. Is that clear?
Yep.
Okay, so on line 50, you make a pet, but when you make a pet, it invokes your constructor. That is a time when that function you have up there, right? That constructor code is invoked.
The constructor was called is invoked.
Yes, constructor call. Yeah, the call is invoking. So yeah, so that is when the constructor is called. Or
I just get confused a little bit because the word constructor kind of means like to build, right?
yes.
Yeah, and we're building the
Well,
specific object of that class.
I thought we were building.
A pet.
Yes, we are building a pet. Okay, yeah. So what is line 23 called? What is this part called? This isn't a
That entire thing, that entire
That's a constructor.
24, 25. Yeah.
So this is a constructor.
That is the body of your constructor, right? That is, we can put more stuff in there. In fact, we are going to put more stuff in there right now. Right?
Okay. Sounds good.
That is the body of the constructor. You can do whatever you want in there, right? In fact, you can go there you can inside your constructor, you can say things like, format the entire world, right? Erase the hard disk. Of course, it's not feasible, right? You can do anything you want there. You can say blow up the whole world. The thing is, that won't be called, that won't be executed until someone makes a pet object.
Makes sense. Yep.
Yeah. Okay. Now we're going to do more stuff right there, right? Inside of 24, we'll do more stuff, right?
Okay.
Now what? But before we go there, I want to. So what this constructor is, this is a special constructor called a default constructor. A default constructor is a constructor that doesn't take any parameters. But remember, the constructor is just a function, right? It's just a function. You can take parameters if you want, right? So, but this is a default constructor, doesn't take any parameters. And it's a special constructor, right? Because a default constructor means that you can invoke the default constructor without parentheses. So further down on line 50, right? On line 50, go line 50. So you see that line 50, you said pet and my pet. You don't have open close parentheses there. You don't have, right? At the end, you don't have open close parentheses. So even though it's going to call your constructor, which is a function, it's not actually being called like it's a function, right? You just say my pet and it makes so it calls a default constructor. Default constructor doesn't take any parameters. And because the default constructor doesn't take any parameters, when you invoke it implicitly like this, you don't have to pass it parameters, open close parentheses. You just call it like my pet and semicolon and it works, right? Now we're going to create another constructor because you can have many constructors, you can have many functions, right? A different signature. And it's called a non-default constructor. And let's try that. Okay, so go up to the declaration of the class under pet, line 13. Open up a line under line 13. Yeah. Okay, now we're going to create a new constructor. It's called a non-default constructor. It takes a parameter, right? So say pet, open parentheses, and then let's say string name equals. Let's give it a default name right there. Actually, let's not go down the default there yet. Okay, just say string name semicolon. It's just close the parentheses. Don't have equals and all, right? So just close the parentheses after the word name, after the name. Yeah. All right. So now you're saying, and in fact, instead of blank line after that, because in the code, usually what people have is we have constructors and destructors in one section, blank line, and getters and setters in another section, blank line. And then people have more methods, more tailored methods for the class. So yeah, you can have a blank space there, but some people don't have. Yeah, cool. Constructors, and then getters and setters. Yeah, setters, and then you can have other custom methods after that. Thank you. Yeah. All right.
Cool.
So we have these two constructors. Now we are going to define this other constructor. So define the body of the second constructor right under there, right after, on line 30. Open a new line, a couple of new lines. Yeah. Okay. Now define the non-default constructor also. So say pet : pet. Now this one takes a parameter.
String name.
Yeah. Right.
Yep.
And then here also put in the diagnostic line at the top saying see out non-default constructor was called, right? So triple click on 29, triple click on 29, triple click.
1, 2, 3. It's not working.
2 clicks. No, triple click should work on a Mac.
This is Replit, so I don't know. Oh, there we go. Cool.
Okay, Command C.
Command C.
Command C.
Yeah, it did it.
Yeah. Now go to 33 and Command V to paste it.
Okay.
All right. All right. So now make that a non-default constructor here. No. In front of the word, non-default constructor was called.
Gotcha.
And you can turn the first one into default constructor was called, right?
Gotcha.
Okay. Now the non-default constructor got passed a name, which means that even at the time the pet is being constructed, the programmer wants you to set the name of the pet. You don't want the default pet, right? So right under there, under the say this arrow name equals name.
Could we instead use the set name function?
Yeah, good point. Okay, and I'm glad you brought up that point. Was it Augie?
Yes.
Okay, yeah. So many people do that. And in fact, there is a thread. There is a thread in Reddit where we talked about this. I think maybe last quarter or quarter before, where many people, even professional programmers, use call setters inside constructors. My personal preference, which you don't obviously have to follow, is never to call any other function inside your constructor. The reason I say that is because constructors don't return a value. right? Constructors don't return, all other functions return a value. So if the constructor failed, you don't have a good way of signaling back to the caller, the person who wants to make a pet object. You don't have a good way of telling them, hey, I tried to make your pet object, but I failed, right? There is a way. There's a way, meaning that there's something called an exception. You throw an exception and it's caught and handled. It's messy, right? It's not messy, but you don't want to go down that road if you can avoid it. I don't, right? So what I try to do is inside my constructor, I try not to invoke other methods. I try to keep my constructors as lean as possible, right? Lean meaning if I'm in my constructor, I just do exactly what I'm supposed to do. Get out of there as soon as possible, right? I don't, inside my constructor, if I call another method and that method does something really wonky and fails, how do I handle that? So Ken Thompson, I think he was one of the engineers who designed the Unix operating system, right? The Unix, which is now running 99% of the whole world, right? The 99% of the whole electronic world is, is being run by something that is Unixy, right? So he made a very interesting observation. I think I don't know which book he talked about it in. Back in the day when I was reading books. Now, in my new home, I don't have any books. The only paper I have is really this, right? Well, actually, no, I do have some books that 4 or 5 books that I value. But back in the day, which book was it? The Unix operating system. I don't know. So he said this, right? Or maybe it wasn't even him. He said, don't test for an error condition that you don't know how to handle. Okay, and I've thought about that line like a million times in my life so far, and I think and I wonder, and every time I think about that, I actually commune mentally with Ken Thompson, his brilliance, right? I don't know if this is what he thought, but just thinking about it and thinking that, wow, he realized that, and he stated that so succinctly, right? Instead of like in a million words like Anand does in his lectures, he just condensed all of that into one beautiful sentence, and that contains all that wisdom, right? So what was that again? He says, don't test for an error condition that you don't know how to handle, right? Because if you say, go do a function, go ahead and do this, and the function says, no, I didn't do it, I failed, but you don't have any way of handling that, and what do you do, right? So always have, if you're going to tell someone to do something, even when you're a manager later on and you got employees, and you say, go ahead and do it, and that person fails to do it, you need to know what to do if they fail, right? And they say, I didn't do it, man, boss, what do I do? And you say, oh, I don't know, man, I asked you to do it, you didn't do it. You're like a totally worst case manager there, right? So you need to know what to do before you tell someone what to do, right? So that is the observation that is very useful in computer science. So don't test for an error condition. So constructors, I don't call setters in constructors, because a setter could fail. But if a setter fails, how do I handle the failure? So so for that reason, also another reason. So there's a very important reason that I think this reason is not appreciated enough by even professional programmers I know, right? So sometimes in the past I've managed some programmers early on, and you look at their code. And then they do it that way. What this gives you the power to, setters validate values before setting them in the right. That's what we do, right? If it's a blank string, don't set it. So setters do this validation. And if you look at a pet object that is created and then filled in using setters only, there's absolutely no way to get an illegal value into your pet, right? You can never make a pet with a blank name or a negative age, because these values are being filtered out by a setters. Yes?
Yeah.
Okay, but sometimes in your code, it is useful to have an illegal object, right? So these illegal objects are called sentinels, because you can look at the object and instantly know it's an illegal object. Right? Because if you see an object with a negative ID, it's an illegal object. So these illegal objects are very useful. And if you don't have any way of creating them, you're basically screwed, because you got to do things the harder way. But if you have an illegal object, known illegal object, it's called a sentinel, right? And it's useful because now if you're processing an entire array of things, you can use these sentinels as markers to say, well, I've hit a sentinel. That means I've processed the first chunk. I've hit another sentinel. I process a second chunk. So sentinels are useful for you in processing data. And when you get to processing large chunks of data, you'll see how useful these sentinels are. Maybe not right now, but later on. So it's, as an example, in C and C++, strings, right? Strings have an illegal character that is used as a sentinel, right? What is the illegal character in strings? An ASCII value of 0, right? 0, the byte 0, the ASCII value 0 is not a valid character in a string. Do you see the 0 value in any of the strings you print? No, you see all kinds of weird values. You even see invisible characters like spaces, tabs, some control characters that don't even appear on screen, but the value 0 doesn't even appear, right? So therefore, the designers of C said, fantastic, right? The string class, an array of characters, actually does give us a sentinel. It gives us an illegal value that I can use. So 0 is used as a marker to signal to you that that's the end of the character array. So when I ask you for the length of a string, you can actually start at the first character and then zip through it until you hit the sentinel, and then say how many characters did I zip through until I hit the sentinel. That's the length of the string. So you see how beautiful that is? It's easy for you to leverage the sentinel, exploit the fact that you have a sentinel. So that's the reason I like to have a way to insert an illegal value inside an object so that I can use the object as sentinel. So this is something that you will actually exploit in when you get to quest 9 or quest 1 of 2B, I actually put this into the quest itself. So you get an opportunity to play with it firsthand and see the value of it, right? So that's why I don't call setters inside my constructors. In fact, I don't call other methods too. And you should be really, really careful to keep your constructors as lean as possible. In fact, you should be super duper careful to keep any method that doesn't signal things back to you, right? If you're going to give control to someone, and then you don't have any visibility into what they do and don't even get them to report back to you saying whether they were successful or not, then you should be like super duper careful to keep that other method highly limited in its scope. Yeah, right? If new employees in your company, new programmers you hire, you don't give them, here you go, change the core search algorithm of Google in your first 5 days on your job, right? You wouldn't do that because, it's a dangerous thing to do. You need to get them to get familiar with everything, and then they go to change some of the core, hardcore code right in the middle. I don't know where we're going with that, but essentially that's basically the thinking behind here. Okay, so what were we talking about? Constructors, right? So yeah, non-default constructor. You set the name. Yeah. Now, where in your main, where's your main, right? When you instantiate the pet, my pet, now you can give it give it a parameter in parentheses. Yeah, give your pet a name. Maybe you call it Laska, like Spot. Okay, Spot. Okay, now if you run it, you'll see that it actually prints the right thing. Okay, my pet Spot, non-default constructor was called. My pet Spot is 4 years old. How cool is that? Right. So these are some important concepts that use constructors. We didn't get around to using static variables, and we have about 20 minutes left. I think we still do the static variables too. But before that, let me introduce something that is also bound to be useful. All right, so this is called a default parameter, right? I don't know whether I should introduce it now. It's going to be useful. All right, I'll just show it to you really quickly. You can think about it. All right, go back to your to the declaration of the pet non-default constructor. Declaration of the non-declaration. I think it's in line 15 or something.
Yeah.
Yeah, right. So there, after name, string name, right? Say name equals no name in quotes. Right now, what that does is don't compile it yet, right? What that does is that because the declaration of the function said that one of the parameters was actually equal to a value, that says that if my non-default constructor was called without giving it a parameter, right? Now make it the same as the default constructor, meaning give that parameter a default value, right? Of no name. So we're going to try compiling it and run it. Compile it and run it now and see what it says. I think it'll give you an error because now you have two default constructors, right? Well, actually, it didn't. But you see how it's worked, right? So the non-default constructor was called. A pet has been created. Pet is wait, and it's a spot.
Should I delete spot?
Oh, of course, yes, right. Yeah. Thank you.
Okay, and then run it.
Yeah, thanks. Right. So now it didn't know which one to call. So hang on. Right. So it's yeah. So what it says, what the compiler is saying there is that, hey, when you call the non-default constructor, you're supposed to give it a parameter, but you never gave it a parameter. You got an open parenthesis and close parentheses. No, I think further down. Yeah. So you got an open close parentheses, but you're not giving it anything. But that is the style for calling a non-default constructor, not a default constructor, right? So if you want to call it, if you want to call the non-default constructor, you need to give it a parameter, right? So in order to make sure, so go back to the top again, go back to the top, and let's get rid of the default constructor altogether, right? Get rid of the first line. No, the first line 14. Right, and in fact, you can already tell that I've forgotten a lot of these things, right? Well, we're just doing trial and error here to see what works and what doesn't, because some of these details I've forgotten. We're going to try and discover together. Okay, now try and compile and run it.
We also need to get rid of the declaration outside of the
comment
thing.
out line 28 to 30 because you don't have a default constructor, right? Comment out line 28 to 30. Yeah. Okay, run it. Does it still have the error?
Did we change the? We didn't change in the definition of the constructor the name equals no name.
Oh
Is
no,
that
yeah, you only specify the default in the declaration, not here, right?
All right.
So what does it say? My bad. Interpreted as empty. Is that so? That's just a warning. Oh, out of line is definition. Yeah, no, out of line is different. Okay, all right. So it just says this is different. Pet colon string name, and there you have pet string name equals no name. Yeah, I got to keep looking at these the syntax details all the time. I'm pretty sure this will fail. Give it an initialization on line 32. I'm pretty sure it'll fail, right? Because I don't think that's allowed. On line 32, string name equals something. It can't be allowed. What if you have something different here and from there? It'll just complain. Yeah, it doesn't like it. Right there, it just got it underlined, right? So you can't have assignment there. So you have the assignment up there as a default value. And all right, now where you call it on line 50, where you call it, just omit the parentheses, right? On line 60, just omit the parentheses and just call it like a default constructor, right? Now run it. Oh, you still have an error? No.
Oh no,
it ran. Wait, I can't. My chat window is covering it up.
So yeah, no name is showing up.
Yeah. Okay. So what happened here is obviously that it did call your non-default constructor properly, as it should, right? Even though that is a syntax for calling the default constructor, the compiler found out that I don't have. Yeah. Here's what happens. Okay. Yeah, I remember now. Right. If you supply a default constructor as well as a non-default constructor, right? This is right here. If you provide both, then no, I'm sorry, erase that. If you provide a non-default constructor, right? If you provide a non-default constructor, the compiler automatically will stop giving it, will not give you a default constructor. You remember how the compiler always gives you a default constructor if you didn't give it one? But if you ended up giving it a non-default constructor, then the compiler says, hey, that person gave me a non-default constructor. I'm not going to give them a freebie default constructor. So if you do that, then you don't get a freebie default constructor. So which you can confirm, right? So go back to line 15 and get rid of everything. No, you can leave the name there, but get rid of equals no name, right? So in other words, you're saying that I have a non-default constructor, except that I'm not going to initialize it there, right? So further down, when you call, yeah, there you go, right? So there it says it takes a parameter, but you're not giving it a parameter, right? Because there's no default parameter.
Yeah, because we commented out.
Yeah. So now it says I won't even compile. If you give it a
Mm.
parameter, it'll make sure that it calls it. And the reason you have it underlined and saying, oh, I can't run it, is because you don't have a freebie constructor anymore. Because you provided a non-default constructor, the freebie constructor disappeared. That's why now you have this underline saying, hey, you're not giving him parameters. The only constructor I know is the one that takes parameter. Does that make sense?
Yeah.
It's underlined now because it doesn't have a freebie, right? On the other hand, if you make that, on line 39, if you put back the default value and say name equals no name, then it says, yeah, okay, now you can call it using default, the usual syntax. But I know that even if you call it, even if I don't give you a freebie default constructor, I know that I can take your non-default constructor and turn it into a default constructor because you've given me the default value for the missing parameter. Does that make sense?
Yeah, I think so.
Fantastic. All right, now, so if you kind of run it, so non-default this call, right? Pet has been, and yeah, okay, so pet no name. So where you have that string name equals, there you go. Right?
I'll get rid of it.
That is a default. So if you didn't provide one, it'll provide one for you. Right? And no, I mean that if the user didn't provide one, you're providing one for the user. Is that clear?
I'm trying to think. So, I mean, yeah, so we don't have it kind of makes sense. So I'm just I need to kind of digest it a little bit.
Take your time, right? We don't have to, we have a lot of time. We can talk about statics next class, right? But it's more important that we all take time to let this sink in, because this is all important, right? I mean, we pour water in the soil and we have to wait until the water sinks into the soil before we pour more water, right? So take your time. Let's make it sink in properly. Then we will march forward. Yeah, we have a lot of time. I promise we'll cover everything, right? I'll cover everything. End of the quarter, I think, I guarantee that we'll be in a position to write some good, interesting programs, all of us.
So basically, because we kind of set name equal to something in the constructor part of things.
Yeah.
C++ basically reads that as a non-default because we're already giving it something. Like we're giving it a value no name. So if I were to like uncomment the default constructor, we got an error here because it was confused.
No, I don't think you'll get an error now.
Should I try running it?
Do you have the default constructor? You do have the default constructor. Yeah. Oh yeah. Now it'll give you an error now because it doesn't know. Run it. Does it run?
I don't think so.
There you go. Yeah. So it gives you an error now because it doesn't know. You have two constructors, doesn't know which one to call.
Yeah, it's confused because on line 62, it looks like it looks like a default, right?
Yeah.
On line 62. However, we gave it a thing in line 15, so
it doesn't know which one to choose.
Yeah, it could be a non-default. It could be a non-default.
Information on how to choose which one. If you provided a name, though, it would be able to run still because it would know which constructor to use.
Exactly. So if you gave it a name Spot, it will know, right? So yeah,
let's try that.
Give it a name. Yeah.
Spot.
Thank you so much, Augie, and all of you, and Momo. Right, this is the way you should learn computer science. So I think, yeah, right, because I've taught, for a while. And I've gone through different ways of teaching computer science and programming. And, traditionally and in the past, it's always been, this is the way you do things, and you have an example program and you study the example program, and it has never worked, because at the end of the quarter, I look at the code that you guys have written, right? I look more at the code that you write in, when you get to quest 6, 7, 8, 9. Then early stages, I don't really look so deeply at your code that you submit, because you're just starting out, and you'll find that, and I found that towards the end of the quarter, if I was teaching the regular way, there's really no market improvement in your code quality, right? There's definitely improvement in regurgitating stuff, because I can see people who studied it and memorized things and just basically vomiting it back out in there. I can tell that's what is going on, and that's what I used to see a lot of. This is the way to learn programming, because even when you're typing it in, it doesn't work. Right? What works is type it in and then make changes, right? Right? And figure out you have to break it. You have to keep on breaking it, right? I think in Facebook, during the early stages of Facebook, I don't know if they still do it. They had a saying, right? You have to move fast and break things, or something like that, right? Because that's the only way to learn. You have to break. And so when you take this, try and break it and fix it, break it and fix it, because you have to say, and that's how you make, then you get to a place where you have something that is breakable, but you're not going to break it because you know how to break it and you know how other people can break it, but only when you've broken lots of things, you know how other things can break. If you've never broken things and you get given perfect things all the time, if all your life, your parents and all these people have been making sure to shield you from all the dangers of life, from reality, as it were, and you're living in a bubble, right? And being spoon-fed information, spoon-fed, and then all of a sudden you get into the external world, you're clueless. You're gonna get killed, right? And that's not the way to learn to live life. That's not the way to learn to program. In order to learn to program or to do something, you got to break. Not break in a bad way, but break so that you know how things break. Right? Not you need to know how to break things, not so that you can go and break things, right? You need to know how to break things so that you know how things break, so you can keep an eye out for it. So when you come across a situation, instantly you know, right? Even if you consciously not know, you instantly know in the back of your head, intuitively, all right, oh, this is a situation I'm being forced. This is a meeting, right? So there's a meeting that I've been called into where people need my opinion. The people are going to talk about these things. Right? Why do people invite you to these meetings? Because you're not going to, it's not that you want, many times you have useful stuff to contribute. No, so it's not even your own genuine idea, but they want you in the meeting because you're a person who has experienced lots of breakages in your life, right? Lots of things in your life have broken, and you have seen it. Maybe you haven't even figured out a solution to these things that broke, but still the fact that you broke them and saw them break is really, really valuable, because there are so many people out there who are scared to break things by themselves because they don't know how it'll break. So they'll bring people in from outside who've seen these things break, right? And say, can you take a look at this? You can sit in our meeting and look at all these intelligent people talking and building this product virtually in their heads in space, right? 10 people are on the table. They're building a product in the middle, a virtual product, because that's how ideas come together, and right. And you're just sitting there as a passive observer, because what are the people hoping to get out of you? They're hoping that all right, Giorgio has broken a lot of code in the past, right? He comes to us armed with 1 million failures, right? So he's a really valuable person to have in our meeting, because he can look, when we're talking, he's not going to talk really. When we're talking, he's going to observe, and because he knows, right? Oh my gosh, that person is proposing an idea that I've tried back in 1975 or something, right? And it broke. Yeah, I can tell that's not going to work. Right? So the more breakages and failures you have in your life, the more valuable you become to other people, because they will call you and say, hey, looks like you have all these battle scars. You have all these battle scars. So we want you to come and tell us how not to get battle scars. Okay, so that's how you learn programming, by breaking things, being bitten by bugs. So when you go out in the field, you have all these bug bites, scar marks on you, right? And yeah, I'm so happy that we managed to get through something and talk, right? You guys, and talk and bring up these points, take this code. See, even as I'm talking, you guys are meddling around with the code, making changes, and I love that. That's the way it should be, right? Because programming is something you can do, because in my mind anyway, when I program, this is how it works, right? 5 minutes I'm thinking intensely about the program and the logic, and I solve the problem, and then the next 5 minutes or 10 minutes I'm just coding blindly coding the idea that has come up in my head. I don't really need to have 100% of my attention in the program. Those 5 minutes, I can think about something else, right? I can think about the next problem to be solved. I can think about, a dance or something, right? Something else that is pleasuring me. So I can do that, and it's alternating, right? It's, as you're coding, it's one foot, you're doing that step by step. And so when you're listening to someone else giving you an idea, when you're listening to me talk, ramble on about useless bullshit, you can code at the same time, right? Because your coding is in spurts, right? Only sometimes you need 100% of your brilliance, right? Other times 90% brilliance. And so that 90% time you can be listening to Augie, listening to someone else, right? And so on. So, and that way you get to build multiplex, timeshare your coding effort, not coding effort, your mental cycles, and you build bigger and bigger, better and better products. Does that make sense? I think we made some good progress today in terms of understanding how objects get created. We talked about constructors and what a default and a non-default constructor is, and when they get called, when they get automatically freely created for you, right? Freebie constructors. All of that is important, right? Because you need to know what is freely available in order for you to not reinvent the wheel, right? Many times in programming, people still still reinvent the wheel, many times in my own code too, even though I know that there's existing solutions. I look at them and say, well, this is fantastic, but unfortunately, it takes me too much effort to meld it into the shape that I want, so I'll just go ahead and create it myself. And you'll do that too many times. But I think it is important to I don't know where we're going with that. All right. So was this useful today? I think to know what's available out there. So all these basic features that need to be second nature, so that you don't go around reinventing the wheel and building it yourself when you can just pick it off the shelf. So that is really what most of 2A is. In 2A, we're just finding out what's on the shelf, what's available, so that you can pick it up. Hey, thank you, Giorgio, for attending. Thank you, guys, all of you guys. I think it's great, and I'm glad that the link has been shared and replete now. So next class we'll just pick it up. We'll pick up this code and run with that. Okay. So thank you. Are you guys coming back? Yeah. Thank you for sharing the code. Yes. Thank you, Sumit. Thank you. Thank you all. Thanks. Yeah. Okay.
Thank you.
Well. Yeah. Oh, I hope you're. You got something out of it, because most of today I realized that I was just blabbering on. So I don't know if you got enough of an opportunity to actually mess with code. Yeah. But I hope you will do that after class today. And again, as usual, right? I have time and I enjoy doing this, right? I enjoy doing this because I'm really looking forward to the day when, I can sit back and watch you guys showcase what you've built. And that will be a treat. That'll be a nice treat for me, right? So if you want to give me a nice treat, thank you, Anand, for teaching us some cool stuff. And that would be a nice way for you to reward me, as take the last class to showcase something that you've built, right? Something you've built. Say, hey, look at something really cool I've made with the knowledge that I gained in 2A. And that way I can end this academic year on a good note and say, hey, and then, you may be surprised. And I think many teachers do that, not just me. Right. In those days, we just think back to some of these good moments in class when some student, displayed some sheer brilliance, right? And we think about that for 10 or 15 seconds and say, yeah, that was really good, right? And but now that's on video, especially since you guys are going and putting in these time marks in there. Now I've actually gone back and watched some of these videos. I click on this link that Zach and some of you put in the YouTube videos, and I rewatched some of these things. And every time, today, Augie or someone says, hey, that's why we do it. Every time I hear that, it gives me a little high, right? Because it just means that someone has just uncovered a little bit of the truth, right? And the more of it just is you see, the more you can see, the more happy you will be, and the more happy I will also be, right? I want everybody to see everything. I don't want anything to be concealed, because anything beautiful to be concealed, right? So there's a lot of beauty in math and art and computer science that just should be open and everybody can enjoy it. All right, so I thank you very much, guys. I hope you guys are coming back on Thursday. Well, it looks like attendance is really solid. It's not dropping off. Usually in the past, I've seen attendance is strong up to the midterm, and then after that it starts trailing off. But we got really strong attendance today too, so I'm very pleased. So obviously, I hope you are getting useful stuff out of it. So I'll see you guys again on Thursday. Oh, Tuesday. All right. So wow. All right. Okay. Yeah. That is week 8. We'll be in week 8 next week. All right. So and next week we'll take constructors, add static variables, and talk a little bit about this other interesting problem we talked about. Unless you have a better idea, right? Sorting and so on. Thank you, Augie. Thank you. Yeah, I'm glad you're finding it engaging, because that's the last thing. Because I could be giving you a lot of useful information, but if it's not engaging, meaning that it's from time to time you got to have interesting stories, a joke, something that happened out there in the news that's interesting that I can share with you. Unfortunately, I don't follow the external world so much, so I can't share the other bits of trivia with you. But I think that is what teachers in general have found to be most effective in retaining your attention, right? Because once you drift off, I've lost you for good. So I have to insert these jokes and things from time to time so that you keep listening. At least, I don't understand the C++, but sometimes Anand tells these stories that are interesting, so I got to keep listening anyway, right? Then as a byproduct, you listen to the C++ things too. Great. All right. I'll see you guys on Tuesday, but always, anytime you want me to talk, I'm happy to talk. Okay. And if you guys want an informal off-schedule lecture, it doesn't have to be about C++. If you have things that you just don't want to, about life you want to talk about, and just want another perspective on life or some matter that is troubling you, I'm happy to talk about those things, right? And obviously, I may not be giving you the best advice, but I'll tell you what I might do in that situation. And then you can say, does it work for me also? You can evaluate that in your head, okay? So I don't think I'm ever going to tell you this is what you have to do, whether it is in programming or in life. It's not up to me, right, to tell you, but I am always happy to tell you what has worked for me, what has worked for me, right? And if you think you're just an ordinary human being like me, right, a normal human being, then these chances are high that what worked for me will also work for you. All right. Thank you so much. It's been a great pleasure. I look forward to these Tuesdays and Thursdays, right? This is a great class. All right. See you guys later. Bye.
Thanks a lot.